So now let us look at the write operation in SRAM. In the previous lecture we have covered the read operation of SRAM. So now let us look at the write operation. Okay, so this is the generic structure of general structure of SRAM that we have seen. So this is one SRAM cell, which of course consists of 6 transistors. Okay, these two form the storage cell or the memory cell, and these two transistors here they form the access transistors. We have seen all this. Okay, and this address decoder selects exactly one word line out of any given n number of word lines. Okay, and then we have seen how these differential read sense amplifiers sense the difference in voltage in this bit line and bit bar line, and read the content of this particular memory location. Okay, so apart from the read operation we also have the write operation. Okay, so for the write operation we have extra circuitry. So like we have read amplifiers for read operation, we have write drivers. Okay, so we have the write drivers for the write operation. So now let us look at the write operation. I somehow feel that write operation is a bit easy to understand, so let us go ahead. Okay, so this is the same thing. Okay, but instead of having the sense amplifiers over here, I have the write drivers over here. Of course there will be sense amplifier above it, but I have removed it so that we can understand this write operation in isolation. Okay, again, so it all starts with the clock again. Okay, so the pre-chargers, okay, the write drivers, the read sense amplifiers, the address decoders, everything has the same clock. Everything runs on the same clock, isn't it, as we have seen in the previous video. Okay, suppose this is the clock on which it is running. Okay, so what happens when clock is 0? When clock is 0, like we have seen in the previous video, this is on, this is on, and this is on, and all these three pass strong ones. And what happens to this particular node is all these are pre-charged to a value of VDD. Very good. Now what happens once a CPU wants to write a value to a particular SRAM cell is the CPU immediately selects the particular storage cell that it wants to write by making the word line signal 1 immediately after clock becomes 1. Okay, so as soon as the clock becomes 1, okay, the word line also becomes 1. Okay, so if the word line selects, suppose for example, let us say this particular storage cell. Okay, so now what happens now is since the clock is no more 0, okay, so this particular nodes now they start to discharge. Okay, so before that let us try to understand the differential write driver. Okay, so once the word line is selected, a particular storage is selected, then the CPU immediately gives out the write enable signal as well. Okay, so this is write enable, which is nothing but this particular signal. Okay, so when this particular signal is high, okay, suppose I want to write a data 0. Okay, so this 0 is now ANDed with this 1, so this MOS transistor sees a 0 voltage at the gate and this is cut off. Okay, because write data is 0, this goes through inverter, this is 1, and write enable is also 1 and 1 is 1, so this transistor is on. Okay, we know that NMOS passes a very strong 0, okay, because this NMOS is grounded over here. What it does is it pulls this particular voltage which has been pre-charged to VDD, it pulls it down to 0, and because NMOS passes a strong 0, and when this potential is 0, this is again another pass transistor, uh, and this word line is also high, and if this is 0, this potential is also 0. Okay, when this becomes 0, okay, this automatically goes through this inverter and this becomes 1. Okay, and this is already pre-charged to VDD. Okay, so no matter what may be the voltage here, because of the memory selection, this potential will be maintained at 1, although this may further go down, because it is held up on a parasitic capacitor, and as time increases it exponentially decreases. Okay, so that is how the write data. So what is the write data that we have chosen here, which is 0? This 0 passes through this NOT gate, the AND gate, this transistor, and via this transistor it now appears at this particular value. So this is where the 0 is written into the RAM storage cell. Okay, now let us look at what happens when write data is equal to 1. Okay, okay, so again the concept is same. Initially when clock is 0, the pre-charge circuit was on, and this particular node, these particular two nodes are pre-charged to VDD. Okay, once the clock goes high, again this particular word line goes high from the address decoder, and if the CPU wants to write do a write operation, as soon as the clock goes high, the CPU also enables the write enable to be high. Once this write enable is high, now we want to write data is equal to 1. Okay, so because this 1 goes here and this write enable is 1, so 1 and 1 gives me 1. So this transistor is on, again this is connected to ground, this NMOS passes a strong 0, so whatever is the potential here, it pulls it down. NMOS is very good at pulling down voltages, so this pulls it down to 0. And once this is 0, again this is a pass transistor, if this potential is 0, whatever may be this potential, this is also pulled down to 0 by this pass transistor. So once this is 0, okay, this inverter now inverts this value, and at this particular point we have the value of 1, and this one goes through this inverter and has a value of 0. Okay, so now whatever data we have written over here, the 1 value now appears in the memory cell at the same point. In the previous case as well, whatever is the write data that we have chosen here, 0, now appears in the memory cell at this location. The same thing is happening even over here. Okay, so here we wanted the write data to be 1, the same data is now appearing at this point in the memory cell. Okay, so write operation is a bit easy, but again in order to summarize, okay, so the first event that takes place is pre-charge, be it write or read. Okay, so this happens when clock is equal to 0. Okay, immediately after clock is 0, okay, usually clock signal is something like this. Okay, immediately after it is 0, it goes on to become high. Okay, so after pre-charge, what happens if the CPU wants to write, okay, with the help of word line, it selects the particular location that it wants to write. Okay, so this is when clock becomes 1, word line is also made 1, and a particular RAM location is selected. then the CPU immediately issues the write enable signal, and this will enable whatever is the write data, okay, to be written to the memory element. Let me call it memory element as ME in the SRAM cell. Okay, so these are the three operations that take this is the sequence of events rather that take place during the write operation. Okay, if you have any doubts, please don't hesitate to call me or mail me or message me. Thank you.